Ce use case est aussi disponible en français. Hi everyone, it's Badr speaking. Today we will strike a very interesting topic, which is at the center of telco marketing: how to develop an attribution model. Business decisions cannot be clearly made if the KPIs are not clearly defined. Let's first welcome my Bitmoji. It will be essential to easily describe the problem. But first, what is an attribution model? An attribution model is a robust way to find the real causes of customers' actions. When sending multiple marketing campaign offers, many actions are essential. One of them is deduplication. Just imagine targeting a customer multiple times. You can imagine the reaction. He can feel he is spammed. Even worse, in case we are targeting a customer with an offer that has no sense. For example, a box offer to someone who has already a box. The customer can feel we are not aware of his situation, causing an early churn. We have to do a real targeting. We cannot leave targeting to luck. Having a good targeting will give the impression to customers that the telco operator they are using is the best, and thus giving to the customer real experience. But the only way to propose customized experience is to understand the causes. By knowing what is working and what is not working, we can understand clearly the efficiency of any marketing campaign. We need to clearly understand the business to take the right actions. When finding the attribution model, we can solve many business use cases. As explained, deduplication is a really important topic. Attribution models will help to not select multiple times the same target and to compute real KPIs. No real dashboard can be made if the business is not clear. Knowing which marketing campaign is successful is the key in our case. Imagine a dashboard using wrong KPIs and insignificant scores. The business can be totally lost. With clear business understanding and machine learning, we can then identify the cause of our customers' actions. To clearly understand the business application, let's consider the following scenario. My telco operator sent me an offer by message with a high discount. I decided to go to the shop nearby my place to get more information around the offer, and I accepted it on site. What was the cause of my decision? The sales channel or the marketing campaign? Without machine learning, the last action will always be considered as the cause. The sales channel will be considered by default as the reason of our reaction, which is totally unfair. But with machine learning, we can find the real cause of each subscription, attributing scores to each marketing campaign, and seeing the impact is how we can switch from reactive to proactive. However, finding the cause is not so easy and it can become very complex. Indeed, telco data hierarchy can easily lead to big data. To understand it, we will have to work on multiple layers. Let's consider a family of three members: Badr, Umayma, and Badr Jr. Badr and Umayma own multiple contracts, but one is used by Badr Jr. The family has at the end 4 contracts. Family ID can then appear multiple times. One mobile subscription used by Badr Jr. and owned by Badr, one mobile subscription used and owned by Badr, and a mobile subscription and the family box contract owned by Umayma. Let's target Umayma. She uses multiple devices. For example, she has a personal computer, a mobile, and a computer at the office. An ID can be to propose a migration to a fiber optic box through a mail. She opened the mail at her office. This mail can be sent by softwares like Salesforce. And we can track the activities using Google Analytics and cookies through her web browser. She saw the offer a first time. She visited the fiber optic web page. and asked questions using the bot. She visited a second time the website by clicking on the link. She looked at the fiber optic page, but this time she added it to the basket and bought the offer. As Umeima got a freshly new box, it is time to propose via SMS the TV package. It is again possible to track her using Google Analytics and keep all the activities via cookies. She clicked on the offer and visited the associated web page. She asked for an advisor to continue the purchase. We can clearly see that all these interactions can lead to a huge data volume which can be very hard to manage. Only advanced analytical database like Vertica can solve this problem. We need to clearly understand the data hierarchy to deduplicate clearly the data and associate each information to the correct customer. In the example, the box is owned by Umeima. Targeting Badr with a box option will be ridiculous. The customer will feel being spammed. The goal of any telco operator is not to have the happiest customer but to maximize the gain. Let's look at the following example to understand the customer's life cycle. At the bottom, there is the excitement meter, and at the right side, the telco money gauge. The higher it is, the more money the telco operator is winning from the customer. The customer has a personal mobile and is searching a new mobile subscription. Why not switching to a free J subscription? This one is not expensive at all, plus it got a huge discount. For this type of acquisition, a natural idea is to target through all the possible channels: mail, SMS, phone call. Now that he has the free J, an easy migration can be made. It is natural to switch to 4J. As there are huge chances of success, the telco operator can limit the targeting by only using an SMS. Indeed, calling customers costs money. It is important to prioritize. With a good 4J connection, it is easier to listen to music everywhere. It is possible to try an upsell. As it is not so important, a mail can be enough. It is the time to propose ADSL, which is not expensive. Wow! We are raising the interest of the customer. We can propose a TV package with it. As it is a very important move, we should target using all the possible channels. He now got a new box that he can use for a long time. But why not proposing the fiber optic option, which is a good fit? It is a little bit more expensive, but it allows high quality content. It is natural to give a little discount at the beginning and to target using different channels like phone and SMS. It is then time to take more money. The discount is over. No need to inform the customer through too many channels. A mail is enough. The customer can then become very angry. It is important to act fast to avoid churn. An idea could be to propose a new discount. It is very important to use all the possible channels to avoid churn. At the end, the most important for the telco operator is to maximize the gain and to avoid churn. We can easily understand that choosing the right marketing campaign at the right moment is essential to drive a business. There are three main channels. Let's consider a customer. He will be targeted by the targeting channel, using many different marketing campaigns. But when he will convert to an offer, he has to go through the sales channel. Each part of a sales channel is linked to one element of the conversion channel. A shop seller converts to the shop he is linked with. A customer who calls the call center will convert to the call center. A sales call to also the call center. But for the web, the conversion channel can be mail, the website, or even SMS can be placed in this category. The goal of creating an attribution score is to predict the right channel and thus to know which marketing campaign worked for each customer. In order to solve the business problem correctly, we will need to build a machine learning model. To understand how machine learning is working, let's take the following example. A machine learning model can identify which is the cause of customers' actions. The telco operator can send multiple offers by mail, SMS, or using the call center. Let's consider a customer who converted. We send him a mail. There are two possibilities. He opened the mail, or he did not open the mail. In all cases, there are three possible sales channels: web, call center, and the shop. If a customer looked at the mail and the sales channel is the web, the model will look at two options: if he clicked or not clicked on the mail, and do some predictions. If he clicked, it is obvious that the mail is the reason of his subscription. Otherwise, it might be the website. Let's go with another example. The call center is the transformation channel. There are two possibilities. It can be a teleseller calling the customer or the customer calling the call center. If it is the teleseller calling the customer, the attribution can be made to the telesales. Otherwise, it is highly probable that the customer is calling the call center thanks to the offer he looked at. For the last example, if the transformation happened in the shop, there are two possibilities. He can either clicked or not clicked in the mail. If he clicked, the mail might be a good reason of a conversion. Otherwise, the shop could be a possible reason. We can get similar results to the other side of a tree, but more focused on the SMS. By fitting the random forest model with the right data, it can then create multiple decision trees like this one. It will then build multiple nodes which are customer actions. It will then pick the most probable event and attribute it to the right marketing campaign. Of course, the model can have multiple errors. The goal is to fit the model with the information we know and we are sure of. It can then learn and help the telco operator to be more proactive. To evaluate the model, we must be careful. For each customer, we can look at what we call the performance funnel. When we target the customer, multiple things will happen depending on his reaction. If he declined one of the funnel steps, the marketing campaign is a failure for the targeted customer. Let's look at one example. We first send the offer. The customer received the offer and looked at it. He can then click on it and accept it. The contract can be then finalized, and the funnel is over. The performance funnel will allow us to evaluate the marketing campaign. Be careful, we need to divide the end of a cycle by the beginning to get a real performance. If, for example, we looked at the number of conversions divided by the number of customers who looked at the offer, we may have high scores which don't make sense. Even worse, if we consider the number of conversions divided by the number of customers who clicked at the offer, the score will be very high because we are considering in our ratio customers that might be interested. Defining the correct metric is really important. Efficient model will only target from the beginning customers that have chances to respond positively to the offer. One of the biggest challenges is creating models and put them into production. If we have no real data structure in our database and our tables are not well organized, even worse, the tables are not created and we are looking with logs and only unstructured data, we will downsample using in-memory technology. After creating the model and doing all the pre-processing, we will need to deploy it in database for this case. It will be really painful and it will need a lot of work, which can lead to a targeting which is not really efficient. We may miss the customers multiple times and still need to work in memory, downsample and find a way to deploy the model. The BI will be very slow. and the data sample used may be incorrect, leading maybe to a crash of a cluster. No one wants such situation. We need an efficient data architecture. Vertica is an MPP columnar database designed for analytics. We can organize all the data into different relations. Use in-database data science in Python and SQL with VerticaPy. It will help us doing the scoring and computing the attribution score, creating a very efficient targeting via Salesforce, and real-time BI with BI tools like Tableau. Proactivity starts here with Vertica. To understand more deeply the use case, let's do some hands-on. We will use Jupyter and VerticaPy to compute our attribution score. We will see how. Ingesting a dataset, doing data exploration, doing features engineering, creating a machine learning model and evaluating it. Let's go! Let's use Jupyter Notebook to illustrate this topic. Let's import the VerticaPy package and its SQL extension. In VerticaPy, it is possible to work both in Python and SQL. All the computations are pushed to Vertica. Be sure to have the same or an upper version to avoid compatibilities issues. For this use case, let's create a new schema. We will name it Telco. We can ingest the first dataset using read CSV. It will use flex table to identify the different data types and store the dataset in the Vertica database. This dataset includes all the marketing campaign information like the timing, the channel, if a target opened the mail. It is the main dataset of the study. Of course, the data were already cleaned and pre-processed to illustrate the use case. A painful data pre-processing phase takes place just right before. We need to gather all the data from the different data sources and clean them, which can be time-consuming. We proceed the same way for the second dataset. This one represents the different customer information like the gender, the tenure, or if he's churning the next month. In VerticaPy, it is possible to easily join the two data sources. We can also compute a variable which is equal to 1 if the customer converted 0 otherwise. As explained during the lesson on correlation and dependencies, it is important to find the cause of any correlation. For example, sales channel is correlated to conversion channel. A naive idea could be to attribute the rewards to the sales channel for each conversion, which is totally unfair. We can also notice a negative correlation between the churn and the conversion. It makes sense as customer who wants to churn will mostly not respond positively to any marketing campaign. Let's now use the eye chart integration to draw a drill-down bar chart. VerticaPy provides integrations with many other libraries. We can notice that most of the transformations are happening through the call center. It makes sense as the telesellers have more chance of persuasion rather than just a mail or an SMS. We can click on it to see more categories. We can see that the box cross-sell is the most occurrent category for the call center. Any new acquisition is indeed very important. We can group the different business targets and compute some aggregations. We can easily see the VerticaPy combination between SQL and Python. The group by statement becomes very easy to manage. Most of the campaigns are upsell or box migration. Customers who are targeted by this marketing campaign have already a subscription with a telco operator and they are easier to convince. The box cross-sell is also a campaign which is very used. The 3 most occurrent campaigns have a much higher conversion rate than the others. It is time to do some features engineering. We can compute for each customer different features, like if he clicked on the link of a specific marketing campaign, if he looked at it, and how he was targeted. Clicks have different meanings for the call center, where clicking means he answered to the phone and accepted the conversation. If he answered and did not accept the conversation, we will consider that he viewed the marketing campaign but he did not click on it. We can then filter by keeping only the customers who converted and drop useless kernel. We have then our clean dataset. We have all the features needed to create a good random forest. It is possible to look at the SQL code generated by the virtual data frame by looking at the current relation. VerticaPy simplifies model and data preparation, deployment, and help creating reusable pipelines. Let's do some machine learning. The randomness will lead to different results for each notebook execution. To get repeatable results, we can seed it. We can create a train and a test set. Get the different predictors. Create a random forest using customized hyperparameters. You can notice that we named the model. It is a particularity of Vertica models. They are built in database using a new C++ implementation. When they are created, they are stored. Thus, they need a name. We can feed the model and compute a classification report. We are dealing with many marketing campaigns and the goal is to predict the conversion channel. The different model scores are excellent for all the categories. The global accuracy is reaching 90%. The confusion matrix is showing that we just got few mistakes. We have a very good attribution model and we can easily determine which marketing campaign is then performant. The leaf chart can help us into finding for which part of the dataset we are making mistakes. In this example, we are predicting 3 times more likely the 90% most probable events. In this case, we can create a more performant model for the last 10% or build some rules thanks to an expert. To understand how our model is predicting, we can look at each tree and understand all the possible actions made by our trees. VerticaPy allows to really simplify the entire data science process and to solve very complex use cases.
Wow, we did a lot. With few lines of code, we solved the business use case. Thanks to Vertica and VerticaPy, everything is happening inside the database. And that's a great asset.
Thank you for watching this video. If you liked it, please visit our GitHub page and add a star to the project. You can also learn more by visiting our website at vertica.com/python. Subscribe to the VerticaPy channel in LinkedIn and in YouTube.
See you soon for another video.